Welcome to Study Loop.
We can write the conductivity, the Q amount of heat in the T time. Conduction can be written as K times the cross-sectional area or the length through which the heat passes times the change in temperature. Then we can write here Q, so our Q can be written as K times A over L times T times delta T. Then we can assume this as a constant and call it alpha. So this becomes alpha times T time delta T, capital T is for temperature. Then our Q becomes alpha T delta T. Um, alpha describes the heat conductivity. Then our assumption for alphas is alpha does not change during the day. Don't change during day. It doesn't change during the day. And the second assumption we have here is alpha is independent of temperature. So independent of temperature. Independent of temperature. Independent of temperature during the day and night. So to keep thermostat up, we need delta Q. So delta Q, which is equal to the heat for not turning down. So for turning down, I will write TED, not turning down, minus the heat for turning down divided by the heat for turning down. This will give us the percentage to keep thermostat up in our model. And for that, we need to find a Q not to turning down and a Q for turning down. We can do that by writing the Q as we did it above. So Q for turning down, TD, can be written as alpha times for 15 hours times the temperature difference, which is 22 minus 8 delta capital T plus alpha times 9 times the temperature difference, so which is 12 minus 0 degrees, and this gives us 318 joules. And for Q, which is not turning down, so not turning down, we can write this as alpha times 15 times the temperature difference, which is 22 minus 8 plus 9 times alpha times the temperature difference here, which is 22. Previously it was 12, now here we have 22, and this gives us the heat for not turning down, which is 408 joules. Then we can plug these values here in above equation. For not turning down, we have 408 alpha. So here I skipped the alpha, so here we have alpha, and here we have alpha also. So alpha joules minus 318 alpha joules divided by QTD, which is a 318 alpha joules. This gives us the percentage of 28%. 28%. So to keep the thermostat up requires 28% more heat in this model than turning it down. End of the problem. Thank you for watching.